Welcome back to Sleep Historian Tales. Tonight, we re-embarking on a fascinating journey into the hidden world of medieval castles. Those magnificent stone fortresses that dominated the European landscape for centuries. For the next 2 hours, we'll explore the incredible secrets, ingenious engineering, and hidden mysteries that lie within these ancient walls. Medieval castles were far more than simple fortifications. They were complex machines of war, symbols of power, centers of administration, and marvels of engineering that incorporated technologies and techniques that would be fully understood or replicated for centuries. Behind their imposing facades lay intricate systems of defense, comfort, and control that reveal the sophisticated minds of medieval builders and the complex societies they served. Tonight, we'll uncover the hidden passages that allowed defenders to move unseen through their own fortifications. We'll explore the ingenious water systems that kept castles supplied during lengthy sieges. We'll discover the psychological warfare built into every stone, designed to intimidate attackers and project the power of their inhabitants across the landscape. From the secret chambers where treasures were hidden to the elaborate mechanisms that operated massive gates and drawbridges, medieval castles were filled with innovations that demonstrate the remarkable ingenuity of their creators. We'll explore how these structures adapted to changing warfare, evolved to accommodate growing comfort expectations, and incorporated advances in technology that made them some of the most sophisticated buildings of their age. So settle in, close your eyes, and let me transport you to a world of towering walls, hidden chambers, and ingenious engineering marvels that continue to amaze and inspire us nearly 1,000 years after they were built. The location of a medieval castle was never chosen randomly. Every successful fortress was positioned according to sophisticated principles of military engineering, resource management, and territorial control that reveal the strategic brilliance of medieval planners. Understanding these principles unveils the first layer of castle secrets, the science of placement that determines success or failure before the first stone was laid. Elevation provided the most fundamental advantage in castle placement. Medieval engineers understood that height offered multiple benefits: superior visibility for detecting approaching enemies, psychological dominance over the surrounding landscape, and natural protection from siege engines that had limited range when firing upward. But the choice of specific elevated positions involved complex calculations about soil stability, water access, and the angle of approach routes that attackers might use. Water sources represented both the greatest necessity and the greatest vulnerability in castle design. A fortress without reliable water would fall to siege within weeks. Yet wells and springs could be poisoned by enemies or fail during crucial moments. Medieval builders developed ingenious solutions to this challenge, creating redundant water systems that included deep wells, rainwater collection, and sometimes secret connections to distant springs through underground channels. The relationship between castles and natural defensive features reveals sophisticated understanding of landscape engineering. Builders sought positions where natural obstacles like rivers, marshes, or steep slopes would channel attackers into predetermined approaches where defensive advantages could be maximized. Some castles were built on artificial islands or promontories that required attackers to expose themselves to concentrated defensive fire from multiple angles. Road networks and trade routes significantly influenced castle placement, as these structures served economic as well as military functions. Castles positioned to control important crossroads, river fords, or mountain passes could levy tolls on merchants while controlling the movement of potential armies. The most successful castles were those that could pay for their own maintenance through control of lucrative trade routes. Climate considerations affected castle design in ways that weren't always obvious. Northern European castles needed different heating systems and weatherproofing than those in Mediterranean regions. Seasonal weather patterns influenced the thickness of walls, the design of roofing systems, and the positioning of structures to take advantage of solar heating or cooling breezes. Some castle locations were chosen specifically to minimize exposure to prevailing winds that could spread fire or make archery defense difficult. Quarry access was a crucial but often overlooked factor in castle placement. The massive amounts of stone required for major fortifications made transportation costs a significant consideration. Many castles were built near high-quality stone deposits, with quarries sometimes integrated into the defensive plan. The type of available stone influenced construction techniques and architectural styles, creating regional variations that reflected local geological resources. Agricultural productivity of surrounding lands determined the long-term viability of castle positions. A fortress that couldn't feed its garrison and dependence from nearby lands would require expensive supply lines that enemies could cut. Medieval planners carefully evaluated soil quality, growing seasons, and agricultural potential when selecting castle sites, sometimes preferring less defensible positions that offered better farming prospects. Political boundaries and territorial claims shaped castle placement in complex ways. These structures often served as symbols of authority over disputed territories, with their positioning making specific claims about the extent of a lord's domain. Some castles were built deliberately on frontiers or contested areas to project power and establish physical presence in strategically important regions. The relationship between multiple castles in the same region reveals sophisticated understanding of coordinated defense strategies. Castle networks were designed so that fortifications could support each other through overlapping fields of observation, coordinated military responses, and mutual supply systems. The spacing between castles was carefully calculated to ensure that attacking forces could and isolate individual fortifications without exposing themselves to attacks from neighboring strongholds. Medieval castle builders were masters of psychological warfare, incorporating sophisticated deceptions and intimidation tactics into their architectural designs. These structures were designed not just to withstand physical attacks, but to demoralize enemies, impress allies, and project power across the landscape through carefully crafted visual and psychological effects. False weaknesses were deliberately built into castle designs to lure attackers into traps. What appeared to be a vulnerable section of wall might actually lead to a killing ground where defenders could concentrate their fire. Gates that seemed lightly defended often opened into courtyards surrounded by murder holes and archer positions. These deceptions required sophisticated understanding of military psychology and the ways attackers typically assessed fortifications. The use of optical illusions in castle architecture created false impressions about the size and strength of fortifications. Walls were built with subtle curves and varied heights that made accurate assessment of defensive capabilities difficult from a distance. Towers were positioned to appear more numerous than they actually were when viewed from likely approach routes. These illusions served to discourage attacks and enhance the reputation of the fortress. Sound amplification systems were integrated into castle designs to enhance the psychological impact of defensive activities. Courtyards and passages were shaped to amplify the sounds of military preparations, making garrisons seem larger and more active than they actually were. Some towers included acoustic features that would amplify war cries, horn calls, or the sounds of weapons being prepared, creating intimidating audio effects for approaching enemies. Color psychology played a significant role in medieval castle design, though much of this has been lost as original painted surfaces weathered away. Many castles were originally painted in colors chosen for their psychological impact. Reds that suggested blood and violence, whites that implied purity and divine protection, or blacks that evoked fear and mystery. Banners, shields, and decorative elements were coordinated to create specific emotional responses in observers. The deliberate display of wealth and power through architectural features served important psychological functions. Elaborate carvings, expensive materials, and sophisticated construction techniques were prominently displayed to demonstrate the resources available to the castle's inhabitants. This display served both to intimidate enemies and to impress potential allies, creating political advantages that extended far beyond military considerations. Scale manipulation was used to create impressions of greater size and strength than actual dimensions warranted. Doorways, windows, and decorative elements were proportioned to make walls appear thicker and taller. Staircases were designed with risers and treads that would tire attackers while allowing defenders to move efficiently. These subtle manipulations required sophisticated understanding of human perception and movement. Strategic use of shadows and light enhanced the intimidating appearance of castles at different times of day. Towers and walls were positioned to cast imposing shadows during morning and evening hours when visibility was optimal. Some architectural features were designed to create dramatic silhouettes that would be visible from great distances, serving as constant reminders of the castle's presence and power. The positioning of defensive features created psychological pressure on attackers by constantly reminding them of their vulnerability. Arrow loops, murder holes, and defensive positions were designed to be visible from approach routes, creating anxiety among attackers who couldn't know which positions were actually occupied. This visible defensive capability often deterred attacks more effectively than the actual military strength behind it. Heraldic displays and symbolic elements were integrated into castle architecture to create associations with powerful families, military victories, or divine protection. These symbols serve to remind observers of the castle's connections to broader networks of power and the consequences of challenging its inhabitants. The psychological impact of these associations could be as important as physical defensive capabilities. The use of captured enemy equipment and weapons as decorative elements sent powerful messages about the castle as military success and the fate awaiting future attackers. These trophies were displayed prominently to create fear and demonstrate the ineffectiveness of previous assault attempts. Some castles incorporated captured siege engines or weapons into their architectural features, turning symbols of attack into symbols of defensive triumph. The hidden spaces within medieval castles represent some of the most fascinating aspects of their design, revealing the sophisticated understanding of security, escape routes, and secret operations that characterized medieval fortress planning. These concealed areas served multiple functions, from providing escape routes during sieges to hiding valuable treasures and enabling covert movement throughout the structure. Secret passages were integrated into castle walls during construction, creating networks of hidden corridors that allowed defenders to move unseen throughout the fortress. These passages were typically built within the thickness of walls, accessible through concealed doors that were often hidden behind tapestries, false walls, or architectural features that appeared to be purely decorative. The engineering required to create these passages while maintaining structural integrity demonstrates remarkable medieval construction skills. Priest holes and hidden chapels served both religious and practical purposes, providing secure spaces for valuable religious artifacts while offering sanctuary during attacks. These spaces were often connected to escape routes that led outside the castle walls, allowing important personnel to evacuate if the fortress was overwhelmed. The location of these hidden religious spaces was typically known only to senior clergy and castle leadership. Treasury chambers were concealed within castle structures using sophisticated hiding techniques that went far beyond simple locked rooms. Valuable items were often stored in spaces accessible only through complex sequences of hidden mechanisms, false floors, or passages that required specific knowledge to navigate. Some treasures were hidden in multiple locations to prevent total loss if one hiding place was discovered. Escape tunnels represented critical elements of castle defense planning, providing last resort evacuation routes for castle inhabitants when fortifications were about to fall. These tunnels were typically dug during initial construction and were carefully concealed both at their castle entrances and their exit points, which might be located hundreds of yards away in forests, caves, or other natural features that provided concealment. Listening posts and spy holes allowed castle defenders to monitor activities in various parts of the fortress without being detected. These concealed observation points were strategically placed to observe great halls, courtyards, gates, and other critical areas. Some listening systems used acoustic principles to transmit conversations from distant rooms to concealed monitoring positions, enabling intelligence gathering within the castle itself. Hidden armories and weapon storage areas were essential for maintaining defensive capabilities during extended sieges. These concealed storage spaces were designed to prevent enemies from discovering the full extent of the castle as military resources, even if they captured significant portions of the structure. Weapons and ammunition were distributed among multiple hidden locations to ensure that some resources would remain available, regardless of which areas fell to attackers. Secret meeting rooms provided secure spaces for confidential discussions about military plans, political negotiations, and other sensitive matters. These rooms were typically accessible only through hidden entrances and were designed with acoustic features that prevented conversations from being overheard. Some included multiple escape routes in case meetings were discovered or interrupted. Concealed water sources and food storage areas were crucial for surviving sieges that might last months or years. Hidden wells, springs, or cisterns ensured that defenders would retain access to water, even if visible water sources were captured or poisoned. Similarly, concealed granaries and food storage areas provided backup supplies that could sustain the garrison when other food sources were exhausted. Torture chambers and prisons were often hidden within castle structures, serving both practical and psychological purposes. These spaces were designed to be accessible to castle authorities, while remaining unknown to most inhabitants and visitors. The secrecy surrounding these facilities enhanced their effectiveness as tools of control and interrogation, while maintaining the castle as public image. Communication systems using hidden passages allowed rapid transmission of messages and signals throughout the castle complex. These systems included horn networks, bell systems, and human messenger routes that could function even when normal movement through the castle was compromised. Some castles included sophisticated signal systems that could communicate with distant allies or other fortifications. The water and sanitation systems of medieval castles represent some of the most sophisticated engineering achievements of their time, demonstrating remarkable understanding of hydraulics, public health, and resource management. These systems were crucial for castle survival and reveal the advanced technical knowledge that medieval builders possessed, often incorporating innovations that wouldn't be widely adopted elsewhere for centuries. Well, systems within castles were marvels of medieval engineering that required precise understanding of geology, hydrology, and structural engineering. Many castle wells extended hundreds of feet into bedrock, with carefully engineered shafts that maintained structural integrity while providing reliable water access. Some wells included multiple chambers and sophisticated pulley systems that allowed efficient water extraction even during sieges when manpower was limited. Rainwater collection systems transformed castle rooftops and courtyards into sophisticated water harvesting networks. These systems included carefully graded surfaces that channeled rainwater into collection tanks, filtering systems that removed debris and contaminants, and storage facilities that could maintain water quality for extended periods. Some castles could collect and store enough rainwater during wet seasons to survive dry periods or sieges. Aqueduct systems connected some castles to distant water sources through ingenious engineering that rivaled Roman achievements. These systems used gravity feed, sophisticated surveying to maintain proper gradients, and innovative construction techniques to transport water across varied terrain. Some aqueduct systems included defensive features that prevented enemies from poisoning or cutting off water supplies. Internal plumbing systems in advanced castles included features that would become common in civilian buildings until much later periods. These systems included gravity-fed distribution networks, primitive but effective sewage disposal systems, and even rudimentary heating systems that circulated warm water through castle chambers. The engineering knowledge required for these systems demonstrates sophisticated understanding of hydraulic principles. Sewage and waste disposal systems in castles addressed significant public health challenges through innovative engineering solutions. Many castles included sophisticated guardrabe systems that used flowing water or deep pits to remove waste safely from living areas. Some systems included multiple levels of waste processing that reduced odors and health hazards, while preventing waste from accumulating in ways that could compromise castle defenses. Hot water systems in the most advanced castles provided comfort and hygiene facilities that were luxurious for their time. These systems included heated baths, warm water for washing, and sometimes primitive central heating that circulated warm water through pipes embedded in walls or floors. The engineering required for these systems included sophisticated understanding of heat transfer and water circulation principles. Water-powered mechanical systems used castle water supplies to operate various mechanical devices, including mills, workshops, and defensive mechanisms. Some castles included water-powered lifting devices for moving supplies, water mills for grinding grain, and hydraulic systems for operating gates or drawbridges. These applications demonstrate sophisticated understanding of mechanical engineering principles. Fountain and decorative water systems served both practical and aesthetic purposes, providing pleasant environments while demonstrating the castle's technological capabilities. These systems required precise hydraulic engineering to create desired visual effects while maintaining practical functions, like providing drinking water or supporting garden irrigation. Water quality management systems address the challenge of maintaining clean, safe water supplies over extended periods. These systems included filtration techniques using sand, gravel, and other natural materials, settling tanks that allowed contamination to separate from clean water, and treatment methods that used herbs and other substances to improve water quality and taste. Emergency water systems provided backup supplies and alternative access methods that could function even when primary systems were compromised. These included hidden wells, concealed cisterns, and alternative supply routes that could be activated if enemies captured or contaminated main water sources. Some emergency systems were so well concealed that their existence was known only to castle engineers and senior leadership. Medieval castle heating and cooling systems reveal sophisticated understanding of thermal dynamics, air circulation, and comfort engineering that challenges common perceptions about medieval living conditions. These systems evolved significantly throughout the medieval period, incorporating innovations that provided remarkable comfort levels while addressing the unique challenges of heating and cooling massive stone structures. Fireplace and chimney systems in castles were far more sophisticated than simple open fires, incorporating advanced designs that maximized heat output while minimizing smoke and fire hazards. Medieval engineers developed complex flue systems that could serve multiple rooms from single heating sources, sophisticated dampers that controlled airflow and heat distribution, and innovative fireplace designs that reflected heat more effectively into living spaces. Underfloor heating systems, inspired by Roman hypocaust technology, were incorporated into some of the most advanced medieval castles. These systems used networks of channels beneath floors to circulate warm air from central heating sources throughout large areas. The engineering required for these systems included sophisticated understanding of air circulation principles and construction techniques that maintained structural integrity while accommodating heating infrastructure. Solar heating techniques were integrated into castle design through careful orientation of buildings, strategic placement of windows, and use of thermal mass to store and release heat. Medieval builders understood how to position structures to take maximum advantage of available sunlight while using thick stone walls to absorb heat during the day and release it gradually during cooler periods. Ventilation systems addressed the challenges of maintaining air quality in large, crowded structures while providing cooling during warm weather. These systems included strategically placed windows, doors, and openings that created air circulation patterns, tower designs that utilized natural convection to draw air upward, and sophisticated understanding of how building layout affected airflow patterns. Central heating systems in the most advanced castles used various techniques to distribute heat from central sources throughout large areas. Some systems used heated air circulation through hidden passages and ducts, while others employed heated water circulation through primitive piping systems. These central heating approaches required sophisticated engineering and maintenance, but provided comfort levels that were remarkable for their time. Cooling systems for warm weather included innovative techniques for reducing temperatures in castle interiors during hot seasons. These systems used evaporative cooling through water features, strategic placement of cooling chambers in underground areas, and ventilation designs that drew cooler air from lower levels while expelling warm air through tower openings. Insulation techniques employed various materials and construction methods to improve thermal efficiency and comfort. Medieval builders used thick tapestries, wooden paneling, and innovative wall construction techniques that incorporated insulating materials between stone layers. Some advanced castles included double wall construction that created insulating air spaces similar to modern cavity wall systems. Thermal regulation systems maintained comfortable temperatures in different areas of castles, according to their specific functions and occupancy patterns. Living quarters required different thermal conditions than storage areas or workshops, leading to sophisticated zoning approaches that directed heating and cooling resources where they were most needed. Heat recovery systems in some castles captured and redirected waste heat from kitchens, workshops, and other heat-generating activities to provide heating for other areas. These systems included flue arrangements that captured hot gases and directed them through heating systems, and thermal mass designs that absorbed excess heat for later release. Seasonal adaptation systems allowed castles to be reconfigured for different weather conditions throughout the year. These systems included movable partitions that could create smaller, easier to heat spaces during winter months, seasonal window coverings that provided insulation or ventilation as needed, and flexible room arrangements that accommodated different seasonal living patterns. Medieval castles incorporated remarkable mechanical systems and engineering innovations that demonstrate sophisticated understanding of physics, mechanics, and automation. These mechanical marvels served both practical and defensive purposes, revealing the advanced technical knowledge that medieval engineers possessed and their ability to create complex mechanical solutions to castle operational challenges. Drawbridge mechanisms represented some of the most sophisticated mechanical engineering in medieval castles, requiring precise calculation of weights, counterbalances, and mechanical advantage. These systems used combinations of pulleys, counterweights, and gear systems to allow relatively small numbers of operators to raise and lower massive wooden bridges. Some drawbridge systems included multiple mechanical stages that could create intermediate positions for different security levels. Portcullis systems employed complex mechanical arrangements to operate heavy iron gates that served as primary castle defenses. These systems typically used combinations of winches, pulleys, and counterweights that allowed guards to raise or lower portcullises quickly in response to threats. Advanced portcullis systems included mechanical locks and release mechanisms that could be operated remotely or set to activate automatically under specific conditions. Water-powered mechanical systems utilized castle water supplies to operate various mechanical devices, including mills, workshops, and defensive equipment. Some castles included sophisticated water wheels that powered grain mills, textile production equipment, and metalworking tools. These systems required precise hydraulic engineering to maintain consistent power output while accommodating seasonal variations in water flow. Lifting and hoisting systems enabled efficient movement of heavy materials and supplies throughout multi-level castle structures. These systems included sophisticated crane mechanisms, pulley arrangements, and winch systems that could lift massive stones during construction, or move heavy supplies to upper levels during normal operations. Some lifting systems were integrated into castle walls and towers in ways that concealed their mechanical components while maintaining operational capability. Timing and automation systems incorporated early mechanical timing devices that could control various castle operations without constant human supervision. These systems included water clocks, weight-driven timing mechanisms, and automated systems that could open or close gates, ring bells, or activate other mechanical devices at predetermined times. Some automated systems served defensive functions by creating the impression of greater activity or vigilance than actually existed. Siege engine mechanisms within castle defenses included sophisticated mechanical devices designed to defend against attacks. These included torsion engines, counterweight catapults, and crossbow systems that were permanently installed within castle structures. Some defensive mechanical systems could be operated by relatively small crews while delivering devastating firepower against attacking forces. Workshop mechanical systems supported various crafts and industries within castle walls, including metalworking, woodworking, textile production, and food processing. These systems often used innovative power transmission methods to distribute mechanical power from central sources to multiple workstations, allowing efficient operation of various productive activities within the castle complex. Communication mechanical systems enabled rapid transmission of signals and information throughout castle structures and to distant locations. These systems included bell networks with mechanical ringing systems, horn systems with acoustic amplification, and mechanical signaling devices that could transmit coded messages over considerable distances. Security mechanical systems incorporated sophisticated locks, latches, and access control devices that protected valuable areas within castles. These systems included complex mechanical locks that required multiple keys or specific operational sequences, hidden mechanical triggers that could activate alarms or defensive measures, and automated security devices that could seal entrances or activate barriers without human intervention. Maintenance mechanical systems supported the ongoing operation and upkeep of castle mechanical equipment through innovative engineering solutions. These systems included lubrication systems for moving parts, adjustment mechanisms that could compensate for wear and environmental changes, and modular designs that allowed replacement or repair of mechanical components without dismantling entire systems. Medieval castles were essentially self-contained communities that required sophisticated food production and storage systems to support their inhabitants, especially during sieges that could last months or even years. The secrets of castle food systems revealed remarkable understanding of agriculture, food preservation, logistics, and nutrition that enabled these communities to survive and thrive in challenging circumstances. Kitchen complexes in major castles were marvels of medieval food engineering, incorporating multiple cooking fires, sophisticated ventilation systems, and specialized areas for different types of food preparation. These kitchens included massive fireplaces capable of roasting entire animals, specialized ovens for bread production, and complex systems of hooks, chains, and mechanical devices for managing cooking over open fires. The scale and sophistication of these kitchen operations could rival those of modern commercial food service establishments. Food storage systems within castles utilized various preservation techniques and storage environments to maintain food supplies for extended periods. These systems included multiple types of storage areas with different environmental conditions: dry storage for grains and preserved foods, cool cellars for perishables, specialized areas for different types of preserved meats, and sophisticated systems for maintaining optimal storage conditions throughout seasonal changes. Granary systems incorporated advanced understanding of grain storage that prevented spoilage, pest infestation, and theft while ensuring reliable access to this crucial food source. Castle granaries used elevated storage systems that protected grain from moisture, and rodents, ventilation systems that prevented dangerous gas accumulation, and rotation systems that ensured older supplies were used before they spoiled. Some granaries included mechanical systems for moving and measuring grain supplies. Brewery and beverage production facilities were essential components of castle food systems, as fermented beverages were often safer to drink than available water supplies. Castle breweries incorporated sophisticated fermentation techniques, quality control systems, and storage methods that could produce consistent, safe beverages for large populations. Some castles included multiple brewing systems for different types of beverages and varying alcohol content levels. Garden and agricultural systems within castle walls provided fresh food supplies and demonstrated sophisticated understanding of intensive agriculture and horticulture. These systems included kitchen gardens with specialized growing areas for different types of plants, herb gardens that provided both culinary and medicinal plants, and sometimes elaborate ornamental gardens that served both aesthetic and practical purposes. Meat preservation and processing systems enabled castles to maintain protein supplies through various preservation techniques, including smoking, salting, and specialized storage methods. These systems included smokehouse facilities with controlled temperature and airflow, salt storage and processing areas, and specialized chambers for different types of meat preservation. Some castles included facilities for processing and preserving fish, poultry, and game animals. Dairy production systems within castles provided fresh dairy products while incorporating preservation techniques that extended the useful life of milk-based foods. These systems included facilities for maintaining dairy animals, sophisticated cheese-making operations, and storage systems that could maintain dairy products in various stages of aging and preservation. Water management for food production incorporated the castle's water systems to support food preparation, cleaning, and various food processing activities. These systems included dedicated water supplies for kitchen operations, drainage systems that managed food preparation waste, and specialized water storage for different food production needs. Emergency food systems provided backup food supplies and alternative food sources that could sustain castle populations during extreme circumstances. These systems included hidden food storage areas, preserved emergency rations designed for long-term storage, and knowledge systems that enabled castle inhabitants to identify and utilize alternative food sources from the surrounding environment. Quality control and food safety systems incorporated various techniques for ensuring food quality and preventing foodborne illness within castle populations. These systems included testing methods for identifying spoiled or contaminated foods, rotation systems that ensured food supplies were used in proper sequence, and cleaning and sanitation procedures that maintained food safety in large-scale food preparation operations. The defensive capabilities of medieval castles represented the cutting edge of military technology and tactical thinking, incorporating sophisticated systems of active and passive defense that evolved continuously in response to changing siege techniques and weapons technology. Understanding these defensive innovations reveals the complex military engineering that made castles effective instruments of medieval warfare. Layered defense systems created multiple barriers that attacking forces would have to overcome, with each layer designed to weaken attacks while providing fallback positions for defenders. These systems typically included outer earthworks and obstacles, multiple walls with different defensive characteristics, towers positioned to provide overlapping fields of fire, and inner keeps that could serve as final refuges. The engineering of these layered systems required sophisticated understanding of how different defensive elements could support each other. Murder holes and trap systems incorporated deadly surprises for attackers who managed to breach outer defenses. These systems included openings in ceilings through which defenders could drop stones, boiling liquids, or other deadly materials onto attackers below. Some murder hole systems included mechanical devices that could deliver these attacks more effectively. and trap systems that could immobilize or injure attackers who entered specific areas. Arrow loops and defensive firing positions were engineered to maximize the effectiveness of archer defenses while providing protection for defenders. These systems incorporated sophisticated understanding of angles, fields of fire, and protection requirements. Advanced arrow loop systems included mechanical devices that could adjust firing angles, protective shields that could be moved to provide additional cover, and ammunition storage systems that kept arrows readily available during combat. Gate and entrance defense systems represented some of the most sophisticated defensive engineering in medieval castles, as these areas were typically the most vulnerable to attack. These systems included multiple gates with different defensive characteristics, complex entrance passages that exposed attackers to concentrated fire, mechanical systems for rapidly sealing entrances, and backup systems that could maintain security even if primary entrances were compromised. Tower defense systems utilized the height advantage of towers to provide superior observation and firing positions while incorporating various defensive innovations. These systems included specialized tower designs for different defensive functions, mechanical devices for operating defensive equipment from tower positions, and communication systems that allowed towers to coordinate defensive activities with other parts of the castle. Wall walking systems enabled defenders to move quickly and safely along castle walls while maintaining defensive positions. These systems included protected walkways with appropriate heights for different defensive activities, storage areas for weapons and ammunition positioned along defensive routes, and communication systems that allowed coordination of wall defenses. Some wall walking systems included mechanical devices for rapidly moving defensive equipment to threatened positions. Counter-siege systems incorporated various techniques and devices designed to neutralize or destroy attacking siege engines and equipment. These systems included specialized catapults and ballistae positioned to target enemy siege equipment, fire projection systems that could set enemy equipment ablaze, and sally ports that allowed defenders to launch surprise attacks against siege positions. Chemical and incendiary defense systems utilized various substances and techniques to create deadly or disabling attacks against besiegers. These systems included Greek fire and other incendiary mixtures, toxic or caustic substances that could be deployed against attackers, and smoke generation systems that could obscure visibility or create breathing difficulties for attacking forces. Psychological defense systems incorporated various techniques designed to demoralize attackers and reduce their effectiveness through fear and confusion. These systems included acoustic devices that amplified threatening sounds, visual displays that suggested greater defensive strength than actually existed, and propaganda systems that spread demoralizing information among attacking forces. Communication and coordination systems enabled effective management of complex defensive operations involving multiple defensive positions and activities. These systems included signal networks that could rapidly transmit information throughout the castle, command systems that coordinated different aspects of defensive activities, and intelligence systems that gathered information about attacking forces and their intentions. The internal organization of medieval castles reveals fascinating insights into social structure, daily routines, and the complex relationships that governed life within these remarkable communities. Understanding the social dynamics and daily operations of castle life unveils another layer of castle secrets, the human systems that made these structures function as viable communities rather than mere military installations. The Great Hall served as the social and administrative center of castle life, incorporating sophisticated systems for managing large numbers of people with different social ranks and functions. These halls included elevated platforms for high-status individuals, complex seating arrangements that reflected social hierarchies, and acoustic designs that allowed effective communication during large gatherings. The Great Hall was essentially a theater of power where social relationships were constantly performed and reinforced. Private chamber systems provided varying levels of comfort and privacy according to social rank, while incorporating security features that reflected the political realities of castle life. Noble chambers included sophisticated heating and ventilation systems, private sanitation facilities, and security features that protected inhabitants from both external threats and internal political dangers. The design and furnishing of these chambers revealed complex status relationships and power dynamics within castle communities. Servant quarters and service areas incorporated efficient systems for managing the large numbers of workers required to maintain castle operations. These areas included specialized living spaces for different types of servants, workshop areas for various crafts and maintenance activities, and storage systems that supported the complex logistics of castle life. The organization of servant areas reflected sophisticated understanding of labor management and operational efficiency. Kitchen and food service operations involved complex social rituals and hierarchical systems that governed who ate what, when, and where. These systems included elaborate protocols for food preparation and service, specialized roles for different kitchen workers, and complex scheduling systems that coordinated food production with social and political activities. The kitchen operations essentially functioned as a complex social machine that reinforced status relationships through food distribution. Religious and ceremonial spaces within castles serve both spiritual and political functions, incorporating systems that supported various religious activities while reinforcing the political authority of castle inhabitants. These spaces included chapels with sophisticated acoustic and visual designs, ceremonial areas for various types of formal activities, and religious artifact storage systems that protected valuable religious objects while making them available for appropriate ceremonies. Educational and cultural systems within larger castles supported various learning and cultural activities that were essential for maintaining the sophisticated knowledge required for castle operations. These systems included libraries with manuscript storage and copying facilities, music and entertainment areas that supported cultural activities, and training areas where various skills were taught and practiced. Economic and administrative systems managed the complex financial and administrative activities that supported castle operations and territorial administration. These systems included treasury facilities with sophisticated security systems, administrative offices where various types of record-keeping were conducted, and storage systems for the documents and materials required for territorial administration. Workshop and craft production areas supported various skilled trades that were essential for castle maintenance and operations. These areas included metalworking shops for weapon and tool production, textile workshops for clothing and furnishing production, and woodworking areas for construction and repair activities. The organization of these workshop areas reflected sophisticated understanding of production management and quality control. Guest accommodation systems provided appropriate lodging for the various types of visitors that political and social obligations required castle inhabitants to receive. These systems included guest chambers with varying levels of comfort and security stable, facilities for visitors' horses and equipment, and reception areas where visitors could be appropriately welcomed according to their social rank and the political significance of their visits. Security and surveillance systems within castles monitored the activities of inhabitants and visitors while maintaining the complex balance of trust and suspicion that characterized medieval political life. These systems included guard posts positioned throughout castle areas, communication systems that allowed rapid reporting of security concerns, and access control systems that regulated movement within different areas of the castle according to social rank and security requirements. The evolution of medieval castles throughout their centuries of prominence reveals fascinating insights into how military technology, social change, and economic factors transformed these remarkable structures. Understanding this evolution unveils the final secrets of medieval castles, how they adapted to changing circumstances, and why they eventually declined as dominant features of European civilization. Early castle development during the 10th and 11th centuries incorporated relatively simple, defensive concepts that evolved rapidly as military threats and construction techniques became more sophisticated. These early structures were often wooden constructions on earthen mounds, but they quickly evolved into more sophisticated stone constructions as builders learned to combine Norman, Saxon, and continental European architectural traditions. The speed of this evolution demonstrates the intense military and political pressures that drove castle development. The golden age of castle construction during the 12th and 13th centuries saw the development of the most sophisticated castle designs, incorporating advanced military engineering, comfortable living spaces, and complex administrative facilities. This period produced the classic concentric castle designs that represented the pinnacle of medieval military architecture. These structures incorporated centuries of accumulated knowledge about siege warfare, comfort engineering, and territorial administration. Adaptation to gunpowder warfare during the 14th and 15th centuries forced dramatic changes in castle design as traditional high walls became vulnerable to cannon fire. Castle builders developed new defensive concepts including lower, thicker walls designed to absorb cannon impacts, angled bastions that deflected cannon fire, and defensive positions specifically designed for early firearms. However, these adaptations often compromised other aspects of castle function. The rise of professional armies and centralized royal power during the late medieval period reduced the military importance of private castles, while changing their social and political functions. Castles increasingly became centers of comfortable noble residence rather than independent military strongholds. This transition required significant modifications to existing structures and influenced the design of new constructions that prioritized comfort over military effectiveness. Economic factors played crucial roles in castle evolution, as the enormous costs of construction and maintenance became increasingly difficult to justify. As military effectiveness declined, the development of more effective siege techniques and firearms made traditional castles vulnerable, while the costs of adapting to new military realities often exceeded the defensive benefits provided. Many castle owners found it more economical to build new, more comfortable residences than to maintain expensive fortifications. Technological obsolescence affected different aspects of castle design at different rates, with some elements remaining useful long after others had become militarily irrelevant. Water systems, sanitation facilities, and workshop areas often remained valuable even when defensive walls and towers had lost their military significance. This selective obsolescence created interesting hybrid structures that combined medieval engineering with later architectural developments. Social and cultural changes transformed how castles were used and perceived, as the feudal social system that had created them gradually gave way to different forms of political organization. Castles that had originally served as symbols of independent noble power became symbols of royal authority, tourist attractions, or simply expensive anachronisms that required maintenance without providing corresponding benefits. Preservation and restoration efforts during later periods reflected changing attitudes toward medieval architecture and history. Some castles were maintained or restored for their historical significance, while others were adapted for new purposes or simply abandoned. The criteria used for these decisions reveal changing cultural values and priorities over the centuries following the decline of castle-based society. Regional variations in castle evolution reflected different local conditions, threats, and resources that influenced how castle technology developed in different areas of Europe. Some regions maintained castle-based defensive systems longer than others, while some areas developed unique adaptations to local conditions that created distinctive architectural traditions. The legacy of castle technology influenced later architectural and engineering developments in ways that extended far beyond military applications. Castle innovations in construction techniques, mechanical systems, water management, and space organization contributed to broader developments in European architecture and engineering. Understanding these connections reveals how medieval castle technology contributed to the broader development of European civilization. As our journey through the hidden world of medieval castles comes to an end, we can appreciate these remarkable structures as far more than simple fortifications. They were complex technological achievements that incorporated sophisticated understanding of engineering, psychology, social organization, and military strategy. The secrets we've explored tonight reveal the remarkable ingenuity and knowledge of medieval builders who created structures that continue to inspire and amaze us centuries after their construction. The engineering innovations embedded in medieval castles demonstrate that the medieval period was far from the dark ages that popular imagination sometimes suggests. These structures incorporated advanced understanding of physics, hydraulics, mechanical engineering, and materials science that enabled remarkable achievements in construction, comfort, and functionality. Many castle technologies weren't surpassed until the industrial age, and some medieval innovations continue to influence modern architectural and engineering practices. The psychological and social dimensions of castle design remind us that these structures served complex functions that extended far beyond military defense. Castles were theaters of power, symbols of authority, centers of administration, and focal points for entire communities. Understanding these broader functions helps us appreciate how castle design reflected and reinforced the complex social relationships that characterized medieval society. The regional and temporal variations in castle design reveal how these structures adapted to different conditions, threats, and cultural influences throughout their centuries of development. This adaptability demonstrates the flexibility and creativity of medieval builders who continuously refined their techniques in response to changing circumstances while maintaining core functional requirements. The integration of multiple complex systems within castle structures, defensive, residential, administrative, economic, and social, represents remarkable achievements in complex project management and systems engineering. Coordinating the construction and operation of these multifunctional facilities required sophisticated planning, resource management, and organizational skills that rival modern construction projects. The decline and evolution of castle technology provides insights into how technological change occurs and how structures adapt to changing circumstances. The transition from military strongholds to comfortable residences and eventually to historical artifacts demonstrates how human needs and priorities evolve while leaving physical traces that preserve past achievements for future study. The preservation and study of medieval castles continues to reveal new secrets about medieval technology, society, and culture. Modern archaeological and engineering analysis methods are uncovering previously unknown aspects of castle construction and operation, demonstrating that these remarkable structures still have secrets to reveal to careful investigation. The influence of medieval castle technology on subsequent architectural and engineering developments reminds us that technological progress is cumulative, with each generation building upon the achievements of previous innovators. The medieval castle builders who created these remarkable structures contributed to a continuous tradition of human technological development that connects us across the centuries. Perhaps most importantly, medieval castles remind us that human ingenuity, creativity, and determination can overcome seemingly impossible challenges. The builders of these structures worked with limited technology, difficult materials, and complex constraints to create achievements that continue to inspire and amaze us. Their success encourages us to approach our own challenges with similar creativity and determination. As you drift off to sleep tonight, let your mind wander through the hidden passages and secret chambers of these remarkable fortresses. Imagine the flickering torchlight reflecting off ancient stone walls, the echo of footsteps in long corridors, and the whispered secrets that these walls have kept for centuries. The medieval castle builders have left us a legacy of wonder, ingenuity, and human achievement that enriches our understanding of what human creativity can accomplish. Sweet dreams, and may your rest be filled with visions of these magnificent stone guardians that have watched over the European landscape for nearly 1,000 years, keeping their secrets while inspiring each new generation to reach for architectural and engineering achievements that seemed impossible to previous ages.